code. Yes. A two-digit number is formed from the first 4 prime numbers. Draw the table to show the possible outcomes. So here we have the word prime numbers. Prime numbers simply means the numbers that are having 2 factors. That is, for us to get these numbers, we can only multiply 1 and the number. Like we can say 1 times 2. There is no any other number that we can multiply to get that. We only have these 2 values. Like we have 2. Consider 4. Is 4 a prime number or not? You'll realize that 4, we have 4 times 1. We have 2 times 2. So this case, there are more than 2. These ones are 4 factors. Factors simply means the multiples, the numbers that can be multiplied to get the other number. So here we have 1, 2, 3, 4. If a number behaves in such a way that it is having more than 2 factors, then it is not called prime number. We call it a composite number. So the first four prime numbers include, we have 2, 3, 5, and 7. Those are the first 4 prime numbers. 1 is not a prime number. So draw the table to show a two-digit number is formed in the first 4 prime numbers. Table to show the possible outcome if it can be used by 1 with the number chosen from the digit. So a two-digit number is formed from the first 4 prime numbers. So we will come up with a table like this. So prime number 1 is not a prime number. I hope that one is well taken care of. So we write 2, 3, 5, 7. There's one here going downwards. We have that. But we are forming. So it means that when we write them going downwards, also we can also write 2, 3, 5, 7. So for us to form them, we just write 2, 2 the way they are here, because they haven't said sum or multiplication. They have just said when you arrange them. So this is 2, 3, 2, 5, 2, 7, 3, 2, 3, 3, 3, 5, 3, 7, 5, 2, 52, yani 52, 53, 54, 55.
Oscar, so inafaa kuwa 55 then 57. Ama ni mimi naona vitu zangu.
Yes, I wanted to see how many people are keen in my class. That's good. That is 55, 57. I thought you are sleeping. So that is 55, 57. Then here we'll have 72, 73, 75, 75, 77. Yes. So we will ask ourselves, what is the possible outcomes? How many numbers do we have inside here? So we just count these numbers that we have here, all of them. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You don't count the outward. These ones you don't count, those prime numbers. These ones are excluded. So the total outcome here, we have 16 outcome. 16 outcome. The first A is answered. That is part A of the question. Draw the table. Calculate the probability that a number chosen from the digits is an even number. Now, when you talk of even number simply means a number that can be divided by 2 without a remainder. So I'll use black color to, so we have 22, 1, 32, 2, 52, 3, 72, 4. So they are only 4. So if they are only 4, we say the observed over the total outcomes, that is a quarter. So we say the probability of getting an even number. Probability of getting even number simply is 4/16, which is a quarter. If it would be an odd number, you'll say P odd. Odd numbers are those numbers that when you divide them by 2, the remainder is always 1. That is the remainder. The remainder is always 1. So from this diagram, you can pick the remaining. That is 23, 25, 27, coming to 77. That is supposed to be 12. 12 over 16. That is 3/4. Let's look at another question on probability. Probably the one of 10 marks question. I believe the first one is that kuna mtu ako na swali? That one is well understood. Very good. Number 2. A bag contains 3 black balls and 6 white ones. If the 2 balls are drawn from the bag one at a time, what is the probability of drawing black ball and a white ball? So the first scenario, they are saying without replacement. Yeah. Now, without replacement, it means that we will start this way. Like we have 3 black balls and 6 white ones. So how many balls do we have in total? That is 9, because it's just one bag. So we say 3 plus 6, that is 9. So we'll have, for black, we'll have 3 over 9. That is for black ball. And then the probability of picking the white one will be 6/9. We say that sum of the probability in a given experiment is supposed to be equivalent to 1. If you're getting more than 1, then it is wrong. Like if I had 3/9 plus 6/9, I am supposed to get 1. So let's start without replacement. Without replacement means nikishachukua, I don't take another one to where I took 1. I just leave it the way it is. So this case, if I pick under black one, if you pick upper, already Yeah, so we're saying that is the one that will be affected. Kama ya kwanza it was 6, so it will now be 5, but the total number will also reduce 8. You have 9 balls in your bag. You already pick one, so it means that the remaining are supposed to be 5 there. And then here will be 10 because we are not picking in black for the second diagram here. That is 3/8, such that when you add the trees branches, you're supposed to get 1. This is a case where we talk of without replacement. You have taken without replacing. Without replacement. Without replacement. But when we talk of with replacement, you take, you return it with another one. So with replacement for a tree diagram, we'll come up with something of this. We'll have black, white. That is black are 3 in total, but the total balls we have is 9. The other case is 6/9. So because we have replaced, when you even pick black, I'll go back, replace it with another black one. So this one will still retain 3/9. 6/9. You are picking and then you are replacing immediately. Black, white. You are picking and replacing what? Immediately, 6/9. So with replacement, it doesn't have any effect. I want you to get the difference here. So this scenario here, we are talking of with replacement. With the replacement. With the replacement. So once we have this tree diagram, we can solve the questions clearly. Sometimes they can ask you to find the sample space. Sample space, just write BB. That is pick black and again pick black. You can also pick black and white. You can also pick white. You can pick white, black. You can pick white, white. This is the third scenario. We can pick black, black. You can pick black, white, black, white, sorry, white, black. And then this is white, white, white. Now, these two experiments, they are different from each other. Let me separate them using a line there, such that you can now see without replacement and with replacement. With replacement, there is an you can see the number is reducing. That is without replacement. So from here, we can solve any question that is brought. So the probability of drawing a black ball and white ball without replacement. So without replacement, experiment yake ndio hii. So without replacement, you are drawing black ball and a white ball. Now, they haven't specified order. You can start with black. So this one, you can say probability of drawing black, white, or I can start with probability of white to black. That case, order is not specified, like some scenarios they normally specify. So if it is specified, then you'll have to obey the order. Let me wrap this side. that I have enough working space. I don't squeeze my items. Wow. So, Roman 1. Roman 1 there. So probability of drawing black and the white ball. So we've said that you can either pick probability of, we can either start with black, then we go to white, or we can start with white, then we go to black. So black, the probability of drawing black. So this case, yeah, the first scenario, you just follow. We agreed that just follow. If it is black, black, this is the way forward. It's wrong tool. This is the way forward. We just take that. Black, black, that is how we go. But we don't want that black, black. So that one is just for demonstration. So we say black, white, or white, black. That is how you follow it. So I come at the other end, say probability of drawing black first is 3/9, and then white becomes 6/9, 6/8, because the population has reduced. Then or simply means you add. Probability of drawing white is 6/9 times black. Probability of drawing black there is 3/8. If you look at that, those lines that I've drawn there, that is equals to 3 plus 3 times 6, you multiply the numerator, that is 18/72 plus 18/72. That is equals to 36/72. You don't add denominator. You only add numerator when we have common denominator. That becomes half. Nancy, are we together?
Yeah.
Good. So this case, we say without replacement. But now, when we come to the second part, which is asking with the replacement, we come down, Sasa. It's different by. So we now go black, white, or we go white, black, because they haven't specified the order. So the order taken, there will be no problem. So again, we just say that it's probability of BW or probability of WB. So that becomes 3/9 times white is 6/9. Plus, because or means plus in probability, 6/9 times 3/9. That becomes 18/81 plus 18/81. That becomes simply 36/81. Of course, you first confirm it, the answers when you're giving must be simplified. Otherwise, Otherwise, it will be wrong. You must simplify your answer. I prefer you give your answer to. Can talk of 9. 9 goes here 4 times. 9 goes there 9 times. Say 9 goes here 4 times. 9 goes here 9 times, 4 over 9. So that is the probability. The answer you're getting must always be less than 1. If you're getting something which is greater than 1 or negative, those ones are not allowed within the probability. We say probability ranges between 0 to 1. That is the range of probability. So if you get something greater than that, your answers zako zinafaa zikuwe in that range. Zaidi ya hapo utakuwa umeambulia patupu. Swahili wasema hivyo. So that one I think is well taken care of. Let's see the second part. Drawing 2 white balls. 2 white balls. So the idea here, simply understand when we talk of without, the number is always supposed to reduce. But with, the number remains constant. So that one is taken care of. What's wrong with the screen? No, the screen is okay, madam. It is you that it's not. Just check the bundles well. You know, these things that are being made by human beings sometimes can be having problem, but it is bundles. Drawing 2 white balls. White balls. So that is without replacement. So part B now. Without replacement would be white. That is, they just want white, pure white. So that is just, I draw white. White. You don't take black now. Draw white twice because they're saying 2 balls here. 2 balls. Our work is just to calculate mathematics, not to even ask ourselves which balls are they talking of. So white here, we have 6 over 9 times 5 over 8. That is without replacement. And this is the way I've reached there. This one, just go white, white. 6 over 9 times 5 over 8. So that becomes 30 over 72. Of course, you don't leave your answer in this format. You must simplify it. That's what the good students normally do. You leave it at that point, you'll be forced. They might consider your answer as so the answer there is 5 over 12. You ask yourself, 6 goes there 5 times, 6 goes here 12 times. Number 2, with replacement. So with replacement, just come down here. In fact, the probability of picking 6 or picking white was 6 over 9, which is not which is retained 6 over 9 because we are not removing any. That is 6 over 9. That is 36 over 81. This one here is what I'm talking of. 36 divided by 81. 4/9. 9 goes there 4 times, 9 goes there 9 times.
Oscar.
Yes, my sweet name.
Yeah, with replacement I was some like 6/9, then the other one ya height ikuwe ni 5/9.
Yeah, then
Yeah, with replacement.
yes.
You can't say like 6/9 the first one, and then the other one it's 5/9, and then ingine 3/9, 2/9.
You know, you can't say that. You can't say
Okay.
that because yes, because we are talking about with replacement. Like you had 5 bob in your pocket, you gave Nancy that 5 bob. Yeah. Then after 6 seconds, Nancy tena alete your pesa. So you still have it. You haven't lose it. So that's why we are
Yeah.
still putting there. With there is no effect there.
Okay.
Yes.
Okay. So
Another example. This one here. Bag. I think all of you at one point have interacted with bag. You know, there's a school where I was teaching, they were asking me, Mwalimu, what is a bag? Okay, bag is something that is used for carrying something. Like you can carry food, you can carry books. A bag contains 6 red beads, 4 and 4 white ones. 2 beads are selected from the bag at random without replacement. Sometimes if they don't say without replacement, just know it is without. If they don't say with replacement, so it's obvious without. So draw a tree diagram. That one is very easy now, considering that we've done the first one there. So we have red, white. So we have 6 red, but the total is 10. 6 plus 4, 10. We have 4/10. Now, because they have talked of the word 2 here, it means they are going for 2 selection. If it would have been 3, then we'll continue up to 3s. But this case, we just go this way. Red, red, go red and white. Talk of red, white, red, white. But now we are under red, so means red is going to be affected. They were 6, now it reduces to 5. There's one that is lost, so the population reduces to 9, not 10. This one is retained. The only thing that will change in this one is the population, that is 4, but it is out of 9, not 10 now. Come to the second scenario. This W here is the one that will guide us. So that is 4/10. So it changes to 3 over what? 9. 4/10. This case, red is not affected, so it just remains 6/9. Then once you've done that, all the questions will be very easy. Like the first one there. Both beads are white. Both of them. So you just say that is probability of white. You pick the first one white and the second one is also white, which means from that probability, that is 4/10 times 3/9. The probability, these are questions that you can do within few minutes if you are well prepared on them. So this is 1, this is 3. This is 2 goes here twice, 2 goes here 5. That is 2/15. 4/10 times 3/9. In that case, both bits are of the same color. That's very easy. It can be either red, or white. Red will be 6/9, 6/10 times 5/9. Or means plus, already we've done white up here, so we can just say 2/15. Don't like repeating yourself. So 6, 3 goes here twice, 3 goes here 3 times, 5 goes here 2 times, and that becomes 1. So that is a third. So if you add a third plus 2/5, and I add a third plus 2/5, 4/15 becomes 7/15. At least a red is picked. So when you talk of at least a red, means that we can have one red in that picking, or we can have even 2 or 2 red going forward. So you will look at that diagram where we have red, like we can have 2 of them, or we can have only ones. That is probability of RR, or complete it. My name is going off. I'm meeting. We have RW W can have WR, or we can there will only be 3, or WR.